In this episode, we are going to take a look at atomic structure and how we can predict the number of various subatomic particles like protons, neutrons, and electrons if we're given just a little bit of information about the rest of the atom. So let's get started with a quick review. We'll begin by taking a look at some information about what we know regarding subatomic particles in the atom.
What makes one substance different from another? What makes the glass in these goblets different from the diamond in this ring? They are both clear, sparkling solids, but diamonds are one of the hardest materials on Earth and are even used to make saws which can cut rock. And glass is fragile, easily broken. The difference lies in the types of atoms that make them up. What makes atoms different from each other? We are going to take a look inside atoms and examine their atomic structure. Atomic structure refers to the arrangement and number of smaller particles of an atom. These smaller particles that make up atoms, or subatomic particles, include protons, neutrons, and electrons. Let us consider each subatomic particle separately. This is an atom of carbon, a substance found in charcoal and diamonds. The nucleus is the center or core of the atom. It is where 99.9% of an atom's weight is located. The nucleus contains protons, as seen here in red, and neutrons, seen here in green. Protons are positively charged particles, symbolized here by a plus sign. All protons are the same, no matter what type of atom they are in. The weight of subatomic particles is measured in units called atomic mass units. A proton weighs 1 atomic mass unit. There are millions and millions of protons in a single drop of water. The other subatomic particles located in the nucleus are neutrons. A neutron is a neutrally charged particle. They do not have a charge. Neutrons also have an atomic mass of about 1 atomic mass unit. While the nucleus contains most of the mass of an atom, it takes up only 1/100,000th of an atom's space, equivalent in ratio to this ball in this meadow. While all atoms have a nucleus, what is it that makes them different? The answer lies in their number of protons. The atomic number is the number of protons in an atom. For example, the element carbon, which is what makes up the graphite in this pencil, has an atomic number of 6. It has 6 protons. All atoms of carbon have the same atomic number of 6. The atomic number also equals the number of electrons. Therefore, carbon also has 6 electrons, seen here in red. Copper, a different element, has an atomic number of 20. It is useful to know the combined number of protons and neutrons in an atom. The atomic mass, also known as the atomic weight or mass number, is the sum weight of the protons and neutrons in an atom. Let's take the element silicon, symbolized by the letters Si. Silicon is a major element that makes up the sand on this beach. Silicon has 14 protons and 14 neutrons that add up to an atomic weight of 28 atomic mass units. While most types of carbon, such as that in these trees, have...
And this is where we'll pause for a moment, as we haven't really gotten into learning about isotopes yet, but that will be next. So what I want to do next to take a look at neutral atoms is just draw and label a neutral atom. You'll see that this is also in your assignment. What we need to have are all subatomic particles in the correct number and arrangement, and we need to include the charges of those subatomic particles. And then, when we're finished drawing one, we'll go look up what atom we decided to draw. So, if I take a look here, I can draw in the center. I'll make my positively charged particles red. These would be the protons. I'll make my neutrally charged particles yellow. These would be neutrons. And then, flying around the outside, I would have some negatively charged particles. These would be my electrons. Remember that all atoms are neutral. So, if I have 4 protons here, I must have 4 negatively charged particles to balance that out here. So I have 4 electrons as well. Then, if I switch over to a periodic table and we look up the number of protons to determine the identity of the element we just drew, let's take a look. An element that has 4 protons would be number 4 on the periodic table, so that tells me I just drew beryllium. Okay, let's continue. Remember the following. This will help us as we fill in the information on our puzzle for the next page. The atomic number is equal to the number of protons. The mass number is equal to the protons plus the neutrons, remembering that we give each of these particles a number of 1. The number of protons should equal the number of electrons in neutral atoms, but not in ions. And this is so that we end up with a neutrally charged atom, because the positives will balance out the negatives. The number of neutrons will be equal to the mass number minus the atomic number, also known as the total between protons and neutrons minus the number of protons. The number of electrons will equal the number of protons so that the atom remains neutral. And once we have those pieces of information put down, now we can take a look at this chart. So if we start with helium, and we see that helium has an atomic number of 2 and a mass number of 4, we can then figure out what the number of protons, neutrons, and electrons is in helium. Remember that the atomic number is equal to the number of protons. So anything in this column is going to equal anything in this column. The number of neutrons is derived from mass number minus atomic number. In this case, that would also be 2. Finally, the number of electrons in any neutral atom has to balance out the atomic number for any atom, so our number of electrons for helium would also be 2. Now let's look at magnesium. Magnesium has an atomic number of 12, so if you look in a periodic table, you would find number 12 in the order of the rows, and then we can take a look at where that should be. This tells me that magnesium also has 12 neutrons, which is not always going to be the same as its number of protons. So if the neutrons are equal to 12, that means our mass number is 24, because to get mass number, you need to add protons plus neutrons to get mass number. Atomic number is going to be equal to the number of protons. Mass number is protons plus neutrons, so we get 24. And then to make the atom neutral, we have to have the same number of electrons as we do protons. Good. Let's move on to zinc. Zinc has an atomic number of 30. So that means it will have 30 protons. Its number of electrons will balance that out to make it neutral. And then to figure out the number of neutrons, we need to subtract its mass number minus its number of protons, giving us 35. Moving on to bromine. This one we're given a little less information, but we know that electrons will be equal to protons, so that the atom is neutral. And then, in order to figure out neutrons, we can subtract 80 minus 35 gives us 45 neutrons. And our atomic number will always be the same as the number of protons. And finally, moving on to aluminum. Our number of protons and our atomic number should be the same. Number of protons and number of electrons should also be the same in order to balance out. And then mass number comes from adding protons plus neutrons. So we get a total of 27. Hopefully that helps you out a little bit. It's your turn now. You can always refer back to this particular demonstration while you're working through the worksheet called A Model Atom. And in that, you are going to continue working through this type of puzzle. If you have questions, please let me know.